out of this, under these kind of conditions, all the way up to 1.5 kilograms of CO2 per cubic meter. And the interesting thing is, as well, is we get simultaneous denitrification. In other words, the faster the ammonia is converted into nitrate, there is still enough space down that the nitrate is also consumed. We get 90% odd denitrification. We have a phenomenal amount of reduced sludge production, and it's been quantified as 70%, 70, humus sludge. That is humus sludge which you don't have to process through an anaerobic digester. It's sludge you don't have to throw into a drying bed or have to incinerate, as you have to do. If you're looking at, it's not very visible unfortunately, activated sludge systems, we've discussed. The plant is designed for about 15 megaliters a day. It takes 20 megaliters a day, and at 15 megaliters it was not able to remove any ammonia. At 20 megaliters, we're converting the ammonia by at least 50%, from 21 down to 7, it's actually more, 60-70%. The same on the treatment filters, and the same for oxidation ponds. You don't have any oxidation ponds in Korea?
No, I don't think so.
No, it's a pity. Okay, but anyway. If we're looking at what can we do, what does Archaea do for your sewage treatment works? You upgrade your process capability. One of the problems, you have to look at the alternatives. How do you upgrade your process capability? Normally, if your flow has increased or your organic loading has increased, what will happen is consultants will tell you you have to double your process capability. You have to build more concrete. You will have to put in more aeration, more sludge handling facilities. We say no, it's not necessary. By incorporating Archaea in your process, you will be able to achieve similar or even better effluent qualities with all the benefits of all these other things. It's less susceptible to shock loads. Our systems, because you are introducing Archaea all the time, it is more stable. Even activated sludge, it can take shocks. It is not, it's very tolerant to hydraulic or organic shocks. The effluent treatability is increased. We have got a plant which gets coffee effluent. Coffee, as you know, contains a lot of tannins. Tannins are extremely difficult to degrade. The plant, before we went on it, the effluent looked like coffee. And with the Archaea, it breaks down the coffee color. And it's actually clear, crystal clear effluent. You are decreasing your sludge production at least 50%, 50%. Your oxygen demand decreases. In other words, if your plant is overloaded, you would require additional aeration to be able to cope with the organic demand, the oxygen demand. We say, if you introduce Archaea, you don't need the capital investment of introducing or buying more aerators, putting in the electricity, the maintenance costs involved. Archaea will remove those metabolic byproducts to methane. And the additional benefit then obviously is the reduced sludge production. We also increase sludge settlability. Even with the current clarifiers, even if the flow rate increases to about maximum, the biomass stays inside, it's not washed out, and your foaming and bulking problems are also alleviated. If you're looking at your anaerobic digesters, we have more gas and less sludge, once again, reducing any downstream impacts. So in essence, you are increasing your nutrient removal, you are increasing or improving your effluent quality, and most importantly, you're reducing your treatment costs. And that's what most people are interested in. Sludge production alone can be about 50% of the operational cost of the treatment works. 50%. Now, if you have to now upgrade your plant, and you have to spend capital, I'm not quite sure how it works in Korea, but in South Africa, you go to the bank, you borrow money, they want interest. That's a lot of money. So there's basically savings all around. Where do we apply Archaea? Basically everywhere. Anything that's biodegradable, municipal sewage, brewing and distillery effluents, tanneries, dairies and food industry waste, anything that's all very high in CODs, abattoirs, paper and pulp industries, all those calcium compounds, petrochemical as I discussed, landfill leachates, textile, and anything basically that is biodegradable. In nature, Archaea has always been there. In our man-made systems, we are trying to optimize on space, on energy, on costs. But in that process, we have sacrificed, we have lost the Archaea. They cannot establish under those conditions. There is too much oxygen. There's too many other organisms. They cannot outcompete them. However, when we create the conditions and we introduce the Archaea at a constant rate, that's when we have all these impacts and we improve system performance. And that's the end.
예, 뭐 질문을